Welcome to all. I am Shikha Rajak from EC third year, and today I am giving a presentation of the subject EC 602 antenna and wave propagation on the topic mechanism of radio wave banding by the ionosphere and critical frequency. So before going to this topic of radio wave banding, we need to understand from where this radio wave came and what is the role of radio wave propagation in the antenna and wave propagation subject. Look, if we want to transmit the information from one device to another device, we need some medium. We need some devices, we need some medium through which we can transmit the information. The information can be a voice, it can be a text, it can be a light in the form of light, it can be in the form of radio frequency signals, which is mainly used for the long distance communication. So if we see, the electromagnetic spectrum is nothing but a spectrum of the electromagnetic signals. What are these? Electromagnetic signals are the combination of electric and the magnetic signals or magnetic fields which are perpendicular to each other, and its direction of propagation is perpendicular to both electric and magnetic field. The whole spectrum is divided into the bands. If we see, we have a power, voice, radio wave, infrared lights, visible light, UV lights, gamma rays, and cosmic rays bands available in the electromagnetic spectrum. Now we need to understand that what are the mediums we used in these bands. you know if we see in the voice band, we are using a cable for transmitting the information. In the visible light, we are using the optical fiber cable for transmitting the information. In the radio wave signal, we are we are taking a free space, or it can be a air, it can be a vacuum. So moving to the next slide, here we have given that what exactly the radio wave propagation is. It is one of the range of electromagnetic spectrum, which is from mainly 3 kilohertz to 300 gigahertz, and it is considered to be the longest wavelength in the spectrum. Longest wavelength of the spectrum means it is used for the long distance communication. Look, radio wave communication is the only communication which is abrupt, which is fast, which is appropriate for the establishment of a good communication. And if you see, it finds its application not only in the transmission of TV signals or for broadcasting purpose, but it also finds its application for transmitting the information, confidential information that we used in the Indian Army securely to the remote areas, or it can also be used in the submarine or in the ships, or as a citizen band radio for transmitting the information. So if we look on the radio frequency and their primary modes of propagation, so we found that the whole spectrum, the whole radio frequency band is divided into very low frequency signal, low frequency, medium frequency, high frequency, and so on. Here you can see that the relation between the frequency and the wavelength is inversely proportional. Means higher the frequency, lower is the distance it will cover, and lower is the frequency, higher the antenna will cover the distance depending on its population density. We have given the propagation via, means the modes it is following, the application of these bands within its frequency range. Now coming to the modes of propagation, we see that the information can be transmitted from transmitter to receiver in one of the following mode, depending on its operational frequency, depending on the area or the distance between the transmitter. We have total three modes of propagation. First one is the ground wave, which is also called surface wave or Norton's wave. What exactly it is? Means it is a wave that is guided along the surface of earth and propagates around the curvature of earth. This type of propagation is guided along the surface of earth and propagates around the curvature of earth. If we see the range of it, then it is up to 2 megahertz, which means that it is used for the long distance communication, and it also includes the medium waves and the very long waves. If we see the application of it, then we find that it is mainly used for the broadcasting purpose. There are basically two phenomena occurs in this ground wave propagation. First one is absorption and the second one is attenuation. The absorption is due to the fact that the radio wave propagates over the surface of earth, and attenuation is due to when the radio wave propagates along the surface of earth. These are some two factors which can be due to the diffraction, which can be due to the irregular surface, and it can also be high because of high frequency. These are considered to be the undesirable factor in the ground wave propagation, which limits its communication, which limits its distance covering area for the communication. If we see the demerit of it, other than this, of high frequency, because it is based on the low frequency signal, which means that it is applicable for the low frequency signals. So if we increase the frequency, then we found that there is a attenuation, and it is one of the demerit of that. And if we see the another demerit of the ground wave propagation, we find that the transmitter and the receiver must be on a considerable distance, and it should not be so far to each other. Coming to the second mode of propagation, that is space wave and tropospheric wave, it is also called line of sight propagation. In this mode of propagation, the EM wave reaches the receiving antenna either directly or after the reflection from the Earth's tropospheric region. This propagation mainly occurs above 30 megahertz. It has application in the television, radar, frequency modulation, etc. It basically works on the very high signals, ultra high signals, and microwave frequency. As it is dealing with a high frequency, so we have these frequency bands which comes under this range. Skywave or ionospheric wave is also called point to point communication or propagation, is having a frequency range from 2 to 3 megahertz, 2 to 30 megahertz, and it is the mode of propagation where the EM wave reaches the receiving point after the reflection from the ionospheric region, which is the uppermost atmospheric layer called ionosphere, and it is situated between 15 km to 400 km over the Earth's surface. It also finds its application in the broadcasting along with the ship and the aircraft communication. Now we need to understand that why all the writer of the book Antenna and Wave Propagation has specified means has given more description on this sky wave or the ionospheric wave or the ionospheric region. We need to understand this. There is speciality in that because we have seen that there is a demerit in the ground and the space wave, which is like the propagation of space and the ground wave are limited by the curvature of earth, and hence this mode of propagation these modes of propagation fail for the long distance communication. That's why we are using the skywave propagations. This topic skywave propagation that we already covered, you know it is the mode of propagation where the EM wave reaches the receiving point after the reflection from the ionized region, and it is situated means after the reflection from the ionosphere, and it is used for the long distance radio communication, and it is also called sky short wave propagation, and these things we already cover up. Now moving to the next slide, we have given the structure of ionosphere, means how the process of skywave propagation goes. Here we have given, the skywave of refracted from some of the ionized layers. This layer is given is called ionized layer, and it consists of ions. If we see, it consists of plasma, which are basically an ions, and which ionized with the action of by the action of solar light. So if we see how the propagation is taking place in this leftmost figure, we find that the sky wave are reflected from some of the ionized layers and reflect back or return back to the earth's surface either in a single hop or in a multiple hops of reflection. By the hop we mean that a jump. You know, we have heard now it's like rabbit's hop. So it is like that only. So this one jump is called hop. So we have seen the means here it is saying that the whole distance can be covered either in a single hop or in the multiple hop of reflections. Now if we see the ionized layer, we find that there is a reason. We have given the troposphere, stratosphere, D layers, E layers, F1 and F2. These are what? From D layer to G region, we have given the ionized region. So we need to understand that what are these. If we see about the structure of troposphere, we find that it is extended up to the height of 15 kilometer from the earth's surface, and it is like the percentage of gas component in this region remains constant, and as we go up to the height, as we go up from the earth's surface, we find that the temperature is also decreases with the increase in height. It is the 80% of air mass. We can also say that because of the varying refractive index with the height, its velocity is also changes, means the wave propagation's velocity changes as the height increases. If we see to the next layer, the ionospheric layer, it is the uppermost part of the atmosphere. This not only heats the atmosphere but also produces ionization, means formation of positive and the negative ions, and it exists between 50 kilometer to 400 kilometer, and hence the skywave propagation takes place in this region. That's why we are also saying this skywave propagation as the ionospheric propagation. It consists of several layers. If we see, as we move to the part, if we are, if we see in this figure, we find that there are some layers: D layers, E1 layer, F1 layer, F2 layer, and G regions. There are basically three principal layers during the daytime. If we see, they are E, F1 and F2 as shown in the figure, and below E there is a D region. If you see that below E there is a D region, so during night time F1 and F2 combines, F1 and F2 layer combines and form one layer called F layer, and D region vanishes altogether. Hence, in the height, E and F layer exist. So during the night time, F1 and F2 layers combine to form the whole single layer, that is F layer, and the D region vanishes altogether. Now if we see the characteristic of each layer one by one, we find that the D layer is 50 to 90 km above the Earth's surface, and it is basically ionized by the photoionization of oxygen molecules, and as we already said that it is present only at the daytime, and it reflects the very low signal and the low frequency signals. In this reason, the frequency communication is not possible. If we see its critical frequency, then we find that its critical frequency is 100 kilohertz, and it is also known as the D region, or the D layer is also known as absorbing layer for the short wave signals. Now coming to the next layer, that is E layer we have given, it is its height is 90 to 140 km from the Earth's surface, and if we see that the E layer is ionized, it is formed by the ionization of all the gases by the soft X-rays radiations. During the night time, E layer is weakly ionized, that is, the electron density we see is low in winter and it becomes high in summer. Its critical frequency is higher as compared to the D region. As we go up to the height, its critical means the critical frequency increases of each layer. So if we see the critical frequency of E region or E layer, then we find it is from 3 megahertz to 5 megahertz. It is also used for the long distance radio propagation during the daylight hours. Its main function is to reflect the high frequency waves in the day hours. If we see the critical frequency of F1 layer, then we find that it is from 5 to 7 megahertz, and F2 layers it is around 10 megahertz.